This is definitely one of those things you tell people not to do at home. I guess we should start adding disclaimers to not follow my lead sometimes.
Well, why are you doing this then?
Because you asked the question and I want you to see. I said, what do you think is inside this?
Oh God. Is it 6 square cells that fit into that shape?
Yeah. Little battery. Yeah, there we go. You know, it's this kind of shit that makes me dangerous. Is that I'll open it up and be like, hey, how does this work? But it's this kind of shit that allows me to learn.
Like, hearing all the stories you've told me, like, this seems pretty low on the risk scale, but, like...
Oh, well, now. So, well, sort of. These kinds of batteries?
Yep.
Not very risky. If I were to try to open up a LiPo battery, all of the risky.
Like, explosion?
Yep, if I puncture it, it's like opening a tiny gate to hell.
So, what's a puncture battery?
So this one actually has longer cells, but it's 6 of them. And each one of the cells is going to meter out at 1.5. How are they connected?
Sequence series.
Series. But by looking at it, like it's not an obvious of how they're set up in series.
Oh wow, they're longitudinal.
Yeah. The last battery I opened that was a 9 volt,
Yeah.
it was actually little flat plates.
Can you take that apart even more?
I've never done that, actually. I was just fascinated to see inside. So we can see the leads. If I pull this, that's the leads coming out. And that's the 2 contacts. So we know that those are the 2 ends of the series cell. So we will use that as a clue to follow where everything else is. Oh, that's poor battery. So you go in and under to that guy. Don't do this at home. Don't do what I'm doing. So this like shrink wrap right here. It's fairly thick. Oh, I used to get so much shit for always cutting towards me.
Yeah.
And everybody's like, no, cut away from your body. But when I was little, my mom would have us peel potatoes every year.
Yeah.
For like the big lunch and stuff. So when you peel potatoes, you do this. So I know the hard stop is where my hand is. But when I cut away from me, I don't know when to stop.
Yeah.
So I cut myself so many more times when I cut away. All right. Meter. All right. Meter. Look how they're connected. Isn't that cool? So now it's way more obvious to see how this is our positive lead. It goes that, goes through there, up, down this one, across, down through those 2. And that's my negative. So let's confirm. Also, this battery is kind of janky on the inside. 8.42. Now what's cool about this is I can go between any of these cells, like just these 2, and I can say, here's my negative start point, and I'll meter here. I'm only going to get 2.8, which is, it would be 3 volts at full charge. But since it's been used a little bit, it's less. But I can measure between any 2 cells or any single cell. So let's do that. Dun, 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 dun. Oh, dude, how cool is that?
Yeah, it's pretty wild.
This is way easier to deal with than the vertical ones, or the discs. All right, let's go ahead and take some notes. This is how we science. So I've got a cell that goes this way, and this is going to be my negative. So this is telling me my orientation between each one of these cells. This will be my positive. So that's my orientation, and they're all connected. So it's in series, it'd be a 1.5 plus 1.5 all the way down to 9, right? But let's science it, because right now if I measure this guy all the way to this guy, I get 8.42. So let's do Alright, I'm going to measure each cell, just because I can. 1.413. Go to this one. And I'm keeping my connectors the same orientation as I go down, because that's how they're connected in series. Interesting. So weird. 1.413. Yep. I go to my next one. What I should be getting is not millivolts. 1.416. Okay. This one. .415. When I say interesting, I was not getting a good contact, and what I will say on that is me not getting a good contact when I'm putting my meter on it is because I'm getting this powdery residue coming out of the batteries, and that's part of like when you open up an old electronic device, like an old Game Boy you haven't dealt with, and it's got this powdery stuff on all the contacts. Yeah. Because the battery itself is like degrading into a mess of non-conductive. 1.404.
Now, are you just trying to like find the collective voltage right now?
Yeah, I mean, I'm trying to see, because I'm curious, and what I think logically makes sense is that all of those in line should give me my voltage of what it is. So I'm curious to see where the cells are. And this is a good practice because when I had to debug why a lead acid battery wasn't working once, you can actually, the microphone keeps hitting my head, you can actually measure like you take your probes and you put it inside the first well for the acid and into the any of the other wells, and you can see the voltage change as you go between, and then you can measure out which well is no longer holding a charge. All right, I have interesting 8.458. So when I measure all the cells, I'm not getting that number is lower than that. Well, okay, so my thought process for why this matters real quick is that if my total voltage was 8.42 and then the sum of each individual cell was 8.458, that there's a chance that some of the electrons when going through the series circuit are actually stopping to level out the other cells as they go forward, because this 1.384 is lower than the others in an odd way. What's cool about this is from one end to the other, I have almost 9 volts, right?
Oh yeah, that's 842.
Yep. Which is not the 8458, which I still think is interesting.
Huh.
What's cool about this though is I go single cell, right?
Yep.
But if I want, I can pull any subset on here. So 3 cells in the middle, I should be getting
423,
which in an ideal world is 4.5 with 3 cells. So that means if I really want, I could have an LED attached specifically to these 3 in a circuit, and one LED attached to these 3.
Aha.
Or if I want to be an asshole, I could have an LED attached to these 3 and one attached to these, so that this cell is just going to be fucking toasted faster.
Dude, that's pretty
right?
sweet.
So
Yeah.
that's a crazy thing of leveraging an already existing circuit
Yeah.
to then find the exact voltage you need. Super fun.
Yeah. All right.
Yeah.
Well, is that it?
I mean, sort of.
Are you gonna blow shit up?
No.
Oh,
Should I?
I mean, it'd be pretty rad.